Alright, hello everyone. Today we're going to be going through momentum and impulse. So momentum and impulse describe how motion and forces are connected over time, and both are fundamental to understanding collisions and force analysis in physics. So to start with momentum, momentum is a product of an object's mass and its velocity. So P equals mv, where P is the momentum, m is the mass, and v is the velocity. Mass is in kilograms and velocity is in meters per second. Momentum is a vector quantity because it has both magnitude and direction. And the direction of momentum is the same as the direction of velocity. So a heavy, fast-moving object will have large momentum, whereas a stationary object has zero momentum, regardless of its mass. All right, so impulse. Impulse is the product of a force and the time interval over which it acts. So the formula for impulse is J equals F times delta t, the change in time. So J is impulse, which is measured in newtons per second. F is the net force in newtons, and delta t is the change in time, or the time interval in seconds. So impulse is also equal to the change in momentum of an object. So this is the impulse momentum theorem. So this is also equal to the change in momentum, which is also equal to mv minus mu. Okay, where v is the final velocity and u is the initial velocity. This means that applying a force over a period of time changes the momentum of an object. A larger force or a longer time interval produces a greater change in momentum. Okay, so now let's go through a worked example. So let's imagine we have a 2 kilogram ball traveling at 3 meters per second, and is brought to rest by a force applied over 0.5 seconds. So it tells us that delta t is 0.5. Determine the impulse and the magnitude of the force. So for this equation, we're going to use this formula here to find the change in velocity. So we're told that it is brought to rest by a force, which means that our final velocity is equal to 0, and its initial velocity, this one here, is our u. Okay, so now we've got everything we need to find the delta p, or the change of velocity. So our mass is 2, so that's our m here. So it's going to be 2 times our final, which is 0, minus 2 times our initial, which is 3. So we have 6. Well, technically -6, because we have 0 minus 6. So we get -6. And because this is impulse, newtons per second. Okay, so the negative sign in this case just indicates that the impulse acts opposite to the initial direction of motion. All right. And then if we were asked to find the force, we could rearrange the equation up here and solve for F as well. So that could be another part of the question. But I think that's a quick summary there of momentum and impulse. So to summarize, momentum is equal to P equals mv, which is a vector quantity measured in kilograms per meters second. Impulse is equal to J equals F delta t, equal to the change in momentum of an object. A net force applied over a time interval changes the momentum of an object by an amount equal to the impulse.